So we'll continue. We'll continue with our inductive effect. See, that was the first part I told you. There are two kinds of inductive effect. One effect is negative inductive effect. We have done what is negative inductive effect. In negative inductive effect, okay, they pull the electron pair towards itself, and that effect is spread in the carbon chain. We know about that. Now, here I am talking about the positive inductive effect. In positive inductive effect, as we know, the group which donates or gives electron pair is known as positive group. For an example, if we have CH3, CH2, 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 and one group is donating a pair of electrons to this carbon atom, and because of that, group develops partial positive charge and carbon develops partial negative charge. But in positive inductive effect, this carbon donates electron to the neighboring carbon, consequently it donates to the neighboring carbon, and this effect is known as positive inductive effect. Is that understood? Correct or not? So over here we'll continue with this. Normally, alkyl groups are positive I groups. Alkyl groups, about them which recently we have studied. Now, positive power of different types of groups and anions. See over here, the tertiary alkyl groups always they are more positive inductive groups than the secondary alkyl groups, than the primary alkyl groups, and I'm going to talk about these two afterwards. Let me explain it. See over here, as I was talking to you, we have different alkyl groups. First of all, each alkyl group is positive inductive group. That means they donate electron. That means they donate electron. Are you following this? What am I trying to explain you? They donate electron. See, we have three kinds of alkyl groups. One was primary alkyl. Second is secondary alkyl, and the third is tertiary alkyl. Now the character of alkyl group is to donate electron. The characteristic of alkyl group is to donate electrons. Correct or not? They are donating electrons. So let's say this primary alkyl group is donating electron to this particular group. Correct or not? Here secondary alkyl group is donating electron, and here tertiary alkyl group is donating electron. What is inductive effect? This donation of electrons spread throughout the chain. Here, suppose this is being donated, so that electron will be spread, the donation of that electron will spread in the chain. But if you see, in primary alkyl group, the carbon which donates electron is attached with only one more carbon, directly attached with one more carbon. So since it is giving electron, it's donating electron, and in support to that, it's another neighboring carbon is also supporting it by donating electron to the carbon. ये कार्बन इलेक्ट्रॉन दे रहा है यहाँ पे बाजू में, तो उसको सपोर्ट कितना कार्बन करता है? डायरेक्टली 1. डायरेक्टली कितने का सपोर्ट? 1. हियर दिस कार्बन इज डोनेटिंग इलेक्ट्रॉन टू द ग्रुप, बट वो सेकेंडरी है इसलिए उसके पास 2 नेबर है. It has 2 neighbors which can support it. This one also can support to give the electron, and this one also can support to give the electron. And in case of tertiary, since it is donating electron to its neighboring group, but it has 3 neighboring carbon which can support to give the electron to the group. क्योंकि उसके बाजू में 3 जुड़े हुए हैं. How many are attached over here? 3. You can see 1, 2, and 3 carbon atoms. So all of them, they are positive inductive group, all 3 of them. But here you can see there are 1, 2, and 3 carbon is supporting the main carbon. Okay, here 2 carbon is supporting the main carbon, and here only 1 carbon is supporting the main carbon. That's why always tertiary alkyl group has higher positive inductive effect than secondary, and then this is decreasing order. Of positive inductive effect. That's the decreasing order of positive inductive. Are you getting this? Okay, let's continue. So that's what it has been explained to us. Positive power of different types of groups. Tertiary alkyl is highest, then secondary alkyl, then primary alkyl. Till here, have you understood? Till here? Okay. Now, these 2 groups are in. Let's next. See, suppose if we have methane, it releases 1 hydrogen, we get methyl, and a group is attached over here. Now this methyl group also has a tendency to donate electron. It also has a tendency to donate electron. Okay, but how many are supporting it? In fact, this is not primary carbon also, because primary alkyl group has at least 1 carbon directly attached to it. Here it doesn't have a primary neighboring carbon. So this group is neither considered as primary, it is called only methyl group. It's known as methyl group. Okay. Since it doesn't have any supporting carbon, so it has lesser positive inductive effect than the primary, secondary, and tertiary. And the least is hydrogen. Have you understood this? On the basis of this, I had explained you in detail. Because on the basis of this, there are lots of concepts which we are going to learn throughout all 4 semesters. Okay. This is alkyl group which is donating electron. This is primary. This is secondary. This is tertiary. Tertiary always have higher positive inductive effect. Secondary has less. Okay. Primary has less. Methyl has least among the alkyl groups. And the least is alkyl से भी least है वो hydrogen. Correct, Devas? Let's continue. All of you are getting this? Anyone has any question over here? You may ask. No issues. It will not look silly, and I will not take your name. So okay. If anyone asks me questions, I will not take your name. So you won't be okay. Ask me. Sure. Let's continue. If you hide your face, then I will take your name. So don't do that. Okay? Next time don't do that. Otherwise you'll be there on Facebook. With proper okay. This is positive power and decreasing order with respect to hydrogen. Is this understood? That was the first effect which we need to understand. Achha, by the way, one more important point. You should have asked me this. Suppose if we have same type of alkyl group, मतलब सबके सब अगर प्राइमरी है या सबके सब अगे सेकेंडरी है तो प्राइमरी सेकेंडरी टर्सरी ऑल दे आर डिफरेंट बॉन्ड्स. अगर सेम टाइप रहते हैं देन पॉजिटिव इंडक्टिव पावर इज प्रोपोर्शनल टू नंबर ऑफ कार्बन. फॉर एन एग्जांपल देखिए, if you have an ethyl group and if you have propyl group, both of them they are primary and butyl group. Okay. All three of them they are primary. Okay. Since it is donating electron over here, but in support there is one carbon. This one is also donating electron over here, but in support there is one carbon and उसके support में भी एक carbon. And यहाँ पे कितने carbon है? 3. As the number of carbon atom increases, so all of them they are primary, but okay, positive inductive power increases. It's directly proportional to number of carbon. Is this understood? Do I need? Yes, tell me. Have you understood? Are you getting this? समझ में आया आपको? I'll go to the next effect. That was the first property which I had explained. Second is resonance. Or mesomeric effect. Resonance or mesomeric effect is like this. First of all, there are certain compounds, okay, which require more than one structure to explain all its property. Okay. See, let me explain. I have one structure. In fact, for carbon dioxide, I have this is one structure. CO2. If you'll ask me how did I get this, let me explain you. Okay. I was talking to you about CO2. Now carbon is in center of 2 oxygen and carbon has 4 valence electrons. Carbon has how many electrons? 4 valence electrons. Let's take it this 1, 2, 3, 4. Oxygen has 6 valence electrons. How many valence electrons? 6. So what they'll do, they'll say okay, 2 electron each. How many electrons they'll say? 2 electron each. So carbon has said 2 electron over here, 2 electron over here, 2 electron over here. Total 4 electrons share किया. In that way, carbon has now got 8 electrons. So carbon का octet complete हो गया है. Octet of carbon is complete. Correct or not? Again, let me draw it. It's like this. Carbon has made double bond over here with oxygen. Here double bond. Correct? Oxygen had 6 electrons. उसने 2 शेयर कर रखे, अभी भी 4 बाकी है. If we consider each bond represents 2 electrons, that means this oxygen has okay 2 bonds, that is 4 electron and 4 okay non-bonding electron. Total 8 है, इसके पास भी 8 है. Is it understood? Clear? Now very important point. Wait and see. Okay. After that, what happens? Okay, this oxygen, due to some reason, what are the reasons we are going to study after this? Suppose it pulls one electron pair towards itself. If they said one electron pair, they said one electron each, and they said, suppose it pulls the electron pair towards itself, then it will become like this. Oxygen already had let me show it to you again. This was the thing. Okay, this oxygen has pulled the electron pair. Oxygen already had 4 non-bonding electron. It has pulled 1 electron pair, so it will develop 6. It will have 6 non-bonding electrons. And what about the other? Here, this oxygen is like, correct? Now, oxygen has pulled the electron towards itself, so it will develop partial negative charge. I'm not saying partial negative charge, that's wrong. Actually, not partial negative charge. I was talking to you about this. This oxygen has pulled the electron pair, so it will develop actual negative charge, not partial negative. So there is a difference between partial negative and negative. In earlier case, bonded electron pair was just pulled. Here, oxygen takes away the full electron pair. Here, earlier case when the partial negative charge was there, oxygen used to just pull the electron towards it. So that's why it was partial negative and this was partial positive. But in this case, it's not pulled, it's actually being shifted. The electron pair has shifted from the bonded pair to the oxygen. And in another word, it's called delocalization. Localization means it remains there. Delocalization, it's moved from its original place and gone somewhere else. Correct or not? Are you following me? Yes or no? Come on. Let's continue. See here, electron pair is just pulled, and here electron pair is shifted. There is a difference. So it develops negative charge, and this carbon develops positive charge. Okay, but now octet of carbon has been disturbed. It has only 6 electrons. So because of that, what will happen? You know, ये वाला oxygen अपना electron pair यहाँ पे देता. Okay, and in that case we get a new structure. Here we are getting structure. यहाँ पे पहले डबल बॉन्ड था, ऑक्सीजन अपना इलेक्ट्रॉन पे देता है, इसलिए ट्रिपल बॉन्ड बन जाता है. इसलिए क्या बनता है? ओके, मैंने बताया यहाँ पे नेगेटिव चार्ज. ओके, कार्बन के पास क्या था? पॉजिटिव चार्ज. Now oxygen is giving its electron pair, so it will develop positive charge, and carbon has gained that electron pair, develop negative charge. So actually, देखो यहाँ पे, this oxygen is giving its electron pair, so it will develop positive charge because it has lost its electron pair, and carbon is getting that electron pair, so it will develop negative charge. One side it has developed positive charge, and one side positive, second side negative. That means neutral. That means what will happen over here? Neutral. Are you following this? So I am getting a new structure. Okay, if I redraw this, if I am getting a new structure of carbon dioxide, this was original structure which we had. One electron pair has shifted towards this side, one electron pair has shifted towards this side. Because of this, here the single bond has taken place, and 6 electrons over here. Here earlier there were 4, now it will remain only 2, and the 3 bonds will take place over here. Okay, carbon is giving away electron, oxygen is taking the electrons, so it develops negative charge. Okay, here oxygen is giving away electrons, it develops positive charge. One side carbon is giving electron, second side is gaining electron, so negative positive become neutral. We don't write anything over there. So we have structure number 1, we have structure number 2. Correct or not? We have another structure also possible. Third structure, it is the other way. This oxygen gives the electron pair, and this oxygen gains the electron pair. So we get 1, 2, 3, 4, 5, 6 negative. Here single bond because the electron pair has gone over here. Carbon 1, 2, 3. Here only 2 electron is gone. It develops positive charge. Have you understood this? Yes or no? Are you getting me? So we have, what have I explained? I have not explained till resonance kya. I have not told you that. I just explained you one compound has three structures. Why three structures? Because sometimes you cannot explain all the properties of carbon dioxide with this structure. Okay. Just for an example, let's say I have 15 properties of carbon dioxide. So out of 15, I may able to explain 9 properties by this structure. But 6 I cannot explain by this structure. Remaining 6, to explain remaining 6, I require another 2 structures. To explain remaining 6, I require another 2 structures. In another way, I can say, if I want to explain all the properties of carbon dioxide, I require more than one structure. What did I say? To explain all the properties of a given compound, I require more than one structure. Then this phenomenon is known as resonance. Then this phenomenon is known as resonance. See, if we see the definition. So definition is like this. Resonance or mesomeric effect. When a molecule or ion can be represented by 2 or more structures which have the same arrangement of atomic nuclei. If we just recap this, थोड़ा fast में draw कर रहा हूँ. This was the first structure which I had. I'm sorry, this was not the first. Okay, just extra electrons. I think this was the first structure. Okay. This was the second structure which I had. And I had another structure. I have 3 structures. Now pay attention over here. The definition, what does it say? It does say, if you have more than, okay, when a molecule or ion can be written by 2 or more than 2 structures, we require at least 2 or more than 2 structures having same arrangement of atomic nuclei. इन तीनों के अंदर आप देखोगे कार्बन की पोजीशन, ऑक्सीजन की पोजीशन तीनों स्ट्रक्चर में सेम है. It has not changed. It has the same arrangement of atomic nuclei, but differs in what? Distribution of electron. तीनों जगह पे इलेक्ट्रॉन का डिस्ट्रीब्यूशन अलग अलग है, but differs in distribution of electron. Then this phenomenon is called as resonance. That's why it's called as. Are you getting me? इसको resonance बोलते. Shall I erase this part? Okay. Continue. The various structure. We got 3 structures of carbon dioxide. All these various structures are called contributing resonating structures. यहाँ तक समझ में आया? और एक बढ़िया चीज. तो लेकिन सर कार्बन डाइऑक्साइड का स्ट्रक्चर कौन सा है? तो तीनों में से. Out of all these 3, yes. Say. The second one. Any other guess? Yes.
Triple bond.
The first one and third one has triple bond.
Like triple combination. Oxygen, triple bond, carbon, triple bond, oxygen.
So do you mean that first and third is the more probable, not the second one? Okay, I like that answer. Anyone else? Okay. 1.9 सच्चा जवाब. Okay. Actually एक ही नहीं. 1.9. एक ही नहीं. Okay. None of the structure is actual. Do you know by the way? In resonance, I have drawn 3 structures. None of the structure is actual. Actual structure is combination of all 3. In chemistry, we use the word is hybrid of all 3. Actual structure is hybrid of all 3, and the hybrid structure which we cannot draw over here. अगर हम उसको ड्रॉ कर पाते तो उसको ड्रॉ करते नहीं है, बाकी तीन को कौन ड्रॉ करेगा? Actual structure cannot be represented. Actual structure is combination of all the structures. Are you following that? and that cannot be drawn or that cannot be represented. Others will represent that only. Why we draw 3? बोले बोले यहाँ पे तो 3 पे अटक गया है. आगे देखेंगे आगे आने वाले समय में 5 5 6 6 7 7 8. Okay, are you following this? Okay, beta, did you get it? That's good. Good answer, Rohan. Let's continue with you. None of these structure truly represents all the properties of the molecular ion. None of them they represent. Okay, all the property. Certain properties are represented by the one. Certain other properties are represented by the second. Correct or not? And the real structure of conjugated compounds is hybrid of all resonating structures. Understood? This phenomenon is known as resonance mesmerism or delocalization. You can see that delocalization. Get it or not? Yes or no? You can see this one. Are you following this? Let's continue. Are you getting me? Okay, there is another structure, resonance of benzene. What is resonance? If we have a compound which has more than 2 structures, in which atomic nuclei remain same, distribution of electrons are different, we call them resonance. None of the structures are actual. They are called resonating structures, and okay, the actual structure will be the hybrid of all of them. Understood? Barabar check. Let's continue further. The structure of benzene. In benzene, I have taught you earlier, we have 6 carbon and 6 hydrogen. Right? If you are absent, then you can see to this point. Or this point, अगर आप लोग absent थे उस time पे. Okay, carbon has 6 carbon and 6 hydrogen, and they have alternative double bond. Correct? This structure is normally represented in this symbolic form. Instead of writing carbon and hydrogen, they just draw a hexagon. Okay, each vertex represents a carbon. Okay, double bond is denoted by double bond. Hydrogen are not required to be shown over here. If there are no hydrogen being shown, that means there are hydrogen are there. Okay, are you following this? So that's the one structure. There is another structure possible. By the way, okay, I had forgotten to explain, inform you that between 2 resonance structure, we normally use a double-headed arrow. Okay. Another structure will be like this. We have 6 carbon and 6 hydrogen. Only difference, the position of atom remains same. Only difference is the position of double bond. You can see that in the first case, double bond are at different places, and here double bond are at different places. Because in resonance, the distribution of electron is different. Are you following this? पता चल रहा है आप लोगों को? That's good. Okay. Let me remove this part. So that's another resonance. I have one more resonance. Nitro is not there in our syllabus at this moment. Okay. But one point you understand. Thus during resonance, I'm explaining you what is mesomers. Okay. Your textbook does not explain this. Resonance I already explained you, okay, where we require more than one structure. But in certain resonating structure, you will see, okay, some of the form has positive and negative charge. This form didn't have any positive negative charge. So if you have positive negative charge, one canonical form has 2 real opposite poles, positive and negative. One terminal there is an accommodation means of charge, and another terminal there is a depletion. Accommodation मतलब negative charge, extra electron है, and depletion मतलब positive charge. Then such type of resonance is called mesomeric resonance, and this effect is called mesomeric effect. Is it understood? Are you getting me? Correct or not? Continue further. That was the second effect. Let's go to the third effect. Electromeric effect. Simple. ध्यान से देखोगे समझ में आएगा. In electromeric effect, it is a temporary effect. It is a, earlier we have studied it was permanent. Resonance is permanent. Okay, inductive effect is also permanent. Okay, and they operates only in pi electrons. मतलब you require double bonds. You require double bond or triple bond. Okay, early inductive effect was only in sigma bonds. That means multiple bonded compounds. Acha, in the presence of some attacking reagents. Okay, in the presence of certain compound only it will take place. Otherwise it will not take place. Otherwise it will not take place. Let me explain. See, let me take it over here. Let me explain it. We are talking about electromeric effect. Actually, I have been depleted, and from my old tools, I cannot use eraser. I cannot use other things. I cannot use. I can use just only pen. There are no chances of making any mistake. Electromeric effect. Okay, let's see in electromeric effect. Let's say I have a compound called. Okay, fantastic. Always keep on smiling. Okay, never give up. If you do mistake, just smile and continue. Okay, let me have another page. Why to cry about it? Correct or not?
Yes.
Okay. What we are talking about? Electromeric effect. Suppose if I have a compound. What's the name of this compound? Anyone? Propanol. Okay. I like that. Say it louder. Acetone. That's correct. Propanol is IUPAC name. Propanol. Stylish propanol. You can say that. Okay, and we have acetone. Okay. अब गिर भी जाओ तो भी हंसते रहेगा. So you just mind. Correct or not? गिरा होगा उसमें. Okay, let's get it. Okay. और E ऊपर से नीचे गिर रहा है यार. Let's continue. Correct? Pay attention. So we have acetone. Okay, in this acetone, what are we going to do? Okay, in the presence of attacking reagent, something happens. See, if this HCN is not there, no issue. Okay, carbon-oxygen bond is a polar bond. It has partial negative charge. It has partial positive charge. It has partial positive charge. Okay, if let's say that this part is not there, this HCN was not there. But as soon as HCN comes, something else happens. Okay, it happens like this. Here, HCN, can I write H plus and CN minus? They are called attacking reagent. They are called attacking reagent. Now, attacking reagent does something. First of all, I think so. We know about this. Okay, this pair was being pulled. Correct or not? This pair was being correct. Okay. Since this pair was being pulled, I may write partial negative and partial positive. Will I be able to write that partial positive and partial negative?
Yes.
Now, in the presence of this, particularly cyanide, okay, which is a negatively charged species, which is a negatively charged species, okay, and normally negatively charged species, they are known as nucleophile. They are known as nucleophiles. They are known as nucleophiles. Phile word is coming from a Greek word called philio. Philio in Greek means to have attraction towards nucleus. Towards nucleus contains what? Proton positive charge. So they have attraction towards proton, and they are always called nucleophiles. And that's why this attacking reagent, they have been renamed. Okay, in so many cases they have been called nucleophilic reagent. Remember that. Normally nucleophilic, not normal. In most of the cases, okay, they are negatively charged, or they have more of electron, or they have lots of electron with themselves. Electron density is high. They are called nucleophilic reagent. Okay. They attack positive charge. Okay. Now onwards, whenever they are going to show you arrow in your book or anywhere, it's always negative charge is going to attack the positive charge. Okay. So they attack this negative charge, and because of that, in the presence of this, okay, ये attack करेंगे, but before attacking something else is happening. Because of that attack, this electron pair shifts to the oxygen. So in first step is this, second step something else happens. Ca3, C, earlier there were double bond, this electron pair shifted here, oxygen gains, already it had 2 electrons to complete its octet. Sorry, 4 electrons to complete its octet. 4 तो already थे, और 2 उसने gain कर लिए. कहाँ से? From this carbon. This carbon has lost its electron to the oxygen, and it will develop positive charge. Earlier it was partial positive, now it has developed positive charge because electron has delocalized. Electron has been delocalized, it has been shifted. Rather said, they have been shifted. The pair has been shifted, and it will develop negative charge. And अभी भी ये यहाँ पे है H plus Cn minus. It has taken place because of cyanide, and further if I'll explain you, in third step, now Cn minus will take on this positive charge. Cn will get, okay, always nucleophile have, always they have at least 1 electron pair extra. At least they have 1 electron pair extra. वो donate करेगा कार्बन को. This cyanide which has extra electron pair donates to the carbon and makes a bond. Since it is donating, cyanide earlier it has negative charge, carbon earlier had positive charge, and after donating that negative and positive becomes neutral. Oxygen still has that extra electron, that's why it's negative. अभी भी हमारा हाइड्रोजन बाकी है. Now, okay, हाइड्रोजन नॉर्मली इस पे अटैक करता है ऐसे बोलते हैं, but it's not like that. I said electron pair will attack this. Negative charge always attack positive, याद रखना. Arrow will be always on like that. Okay, and the next step, Ca3, C, Cn, CH3, OH. That's the complete reaction. If you see the sequence, earlier acetone, it was only, you can see it over here, earlier it was only, and may not be able to highlight this also. I may be. No. Okay. Earlier it was only polar bond. Earlier it was only polar bond. In the presence of cyanide, okay, that bonded pair of electron has shifted towards oxygen, attacking reagent presence. That's why it's temporary effect. If it was not there, nothing was happening. As soon as HCNS came, electron pair has shifted to the oxygen, then cyanide attack. Cyanide यहाँ पे जो हुआ, ऑक्सीजन हाइड्रोजन पे अटैक किया, एंड ये पूरा रिएक्शन हुआ. आपके बुक में ये नहीं समझाया, पूरा इस तरीके से नहीं समझाया. I'd explain with an example. Okay, they are not teaching you wrong concept, but not in detail. The book has the same concept, but it talks about only CO, which में पूरा सब कुछ नहीं बता रहा. Are you following this? The shifting of electron pair in the presence of some reagent is known as electromeric effect. Shifting of electron pairs. As here, it is temporary effect. It operates only in pi bond. Okay, multiple bond compounds, presence of some attacking reagent. It is externally induced. Externally induced हुआ ना? Externally induced मतलब किसी और ने ये किया. उसका खुद का नेचर नहीं है. It doesn't have its own nature. Because someone does it. Because someone does it. Okay, HCN था आया उसने चालू किया ना ये. Correct or not? Okay. In polar bonds, okay, polar bond होना जरूरी था. Carbon oxygen bond was polar. We know that partial negative and partial positive charge था. In polar bonds, in presence of attacking reagents, a complete transfer. It is a complete transfer of electron. Electron पे पूरी transfer हुई थी कार्बन से ऑक्सीजन की ओर. Okay, one pi bond electron पे two कहाँ पे transfer हुआ? More electronegative atom. Oxygen was more electronegative. Takes place. For an example, in carbon oxygen double bond, in presence of nucleophiles like cyanide, HSO3 minus, okay, pi electron shifts towards oxygen. That phenomenon is known as, okay, electromeric effect. बराबर है. यहाँ पे थोड़ा गड़बड़ घोटाला हो गया. वही चीज है जो मैंने आगे आपको समझाई. अच्छा, by the way, note that since electron pair is moving away from the attacking reagent, आपने देखा ये, okay, attacking reagent यहाँ पे आ रहा है और इलेक्ट्रॉन पेयर उससे दूर भाग रहा है. अटैकिंग रिएजेंट यहाँ पे है ना, देखो अटैकिंग रिएजेंट यहाँ पे अटैक कर रहा है, इलेक्ट्रॉन पेयर कहाँ जा रहा है? उसके ऑपोजिट डायरेक्शन में. Then that is known as negative electromeric effect. Negative E effect. Then that is known as negative E effect. Is it understood? Continue करेंगे. Okay, we got another negative, electromeric effect. Let me explain it two parallel effects. So I'm taking to the other board. We have already learned negative electromeric effect. Okay, we have another compound. Let's say carbon double bond. Ethene is there. कौन सा है? Ethene. मतलब right here. And we are reacting with HBr. इसके साथ रिएक्शन हो रहा है. By the way, इस बार डबल बॉन्ड है लेकिन पोलर बॉन्ड नहीं है. Last time we had a polar bond. How can you say that, sir? Because carbon oxygen electronegativity was different. Here carbon has a double bond. Its electronegativity is same. So it's not polar. It's not non-polar. It is non-polar. Okay? जब non-polar होता है तब इलेक्ट्रोफाइल अटैक करता है. जब पोलर होता है तब न्यूक्लियोफाइल अटैक करता है. सर ये इलेक्ट्रोफाइल क्या होता है? ओके, न्यूक्लियोफाइल का उल्टा है. सर कजिन ब्रदर ही, लेकिन उससे थोड़ा ऑपोजिट है. न्यूक्लियोफाइल हैज अट्रैक्शन टुवर्ड्स न्यूक्लियस. इलेक्ट्रोफाइल अट्रैक्शन हैज टुवर्ड्स इलेक्ट्रॉन्स. एंड इलेक्ट्रॉन्स की ओर नॉर्मली पॉजिटिव चार्ज को अट्रैक्शन होता है. बराबर ना
बराबर सर
समझो
हाँ सर
okay let's continue okay so over here so here we have HBr actually HBr I may write okay in this manner H plus Br minus इस बार पॉजिटिवली चार्ज जिसको हम बोलेंगे ओके इलेक्ट्रोफाइल okay it will get attracted towards this electron okay double bond is rich in electron दो बॉन्ड बना रहे हैं उसकी इलेक्ट्रॉन डेंसिटी हाई होती है करेक्ट और नॉट इट इज हाई इलेक्ट्रॉन डेंसिटी so they will get attracted over here because of that अच्छा वो कौन से कार्बन के नजदीक में था there are two कार्बन 1 and 2 obviously right hand side कार्बन नंबर 1 की ओर नजदीक में H plus so because of that this electron pair will transfer over here जैसे इसमें ऑक्सीजन की ओर गई थी ना इलेक्ट्रॉन पेयर यहां पे ये इलेक्ट्रॉन किसके पास जाएगी कार्बन के पास दैट्स द ओके नेक्स्ट स्टेप ओके एंड यहां पे एक इलेक्ट्रॉन पेयर एक्स्ट्रा आ गई okay is it those two dots and that's why it develops negative charge this develops positive charge अभी भी रिएक्शन हुआ नहीं ये हो गया हमारा इलेक्ट्रोमेरिक इफेक्ट okay moving of electron pair in the presence of some attacking reagent now attacking reagent will attack actually ये इलेक्ट्रॉन पेयर अटैक करती है जैसे मैं आपको पहले बताया इलेक्ट्रॉन पेयर will attack H plus correct or not and H plus will get connected over there and यहाँ पे H plus positive and okay hydrogen has a positive charge carbon had a negative charge so it become neutral ये वाला अभी भी पॉजिटिव है और अभी Br minus बाकी now Br minus will attack over here and पूरा complete reaction are you following this but understand one point okay this hydrogen was attacking reagent here hydrogen was attacking reagent and इस बार इलेक्ट्रॉन पेयर उसकी ओर गई जो शिफ्ट भी हुए उसकी ओर हुई that's why this is known as positive electromeric effect that's what is known as are you following this समझ में आ रहा है कि नहीं आ रहा है here H plus ion यहाँ पे दिखाया गया C double bond C okay H plus and Br minus okay in the presence of H plus electron pair is shifted to this carbon you can see negative charge and H plus उसके साथ जुड़ा correct or not yes or no अपने बुक में ऐसे दिखाया your book shows like this but I explain the full reaction कैसे होता है okay since electron pair is moving towards attacking reagent is known as positive inductive effect hyperconjugation next time okay I hope you people have understood yes or no